Thank you guys for joining me today. In this video, I will start to introduce what is the meaning of stress. So previously in engineering mechanics, statics, we learned that if we have any structure under the effect of external forces, these external forces will create internal forces in four forms. Actually, we focused on three forms, but actually they are four forms. The first one, axial force, shear force, bending moment, and torsion. The first three forms covered in statics. So if we have a beam and this beam is supported by two supports, and we have external forces in terms of distributed load, concentrated forces. These forces are called external forces. These external forces will create internal forces. We learned before that we can draw axial force diagram. We can draw shear force diagram. We can draw bending moment diagram. I would like to add that we have another diagram which is called torsion diagram. It will be covered in more details in this course. These internal forces that we learned before will cause stresses. This is the topic in our course, in this course, Mechanics of Material. We will convert the internal forces, which are coming from the external forces, to convert them to stresses. Later in different courses, we are going to use these internal forces to make design. So remember, these internal forces can be axial force, tension, or compression. These internal forces can be shear, perpendicular to the member. These internal forces can be moment, bending moment. These internal forces can be torsion. This is the shape of the torsion. Torsion means twisting. So if you have these internal forces in the member, these internal forces will cause stresses. So it's very important to understand this sequence. If you have a member under the effect of external force, the external force will create internal forces. These internal forces can be axial force, tension or compression, shear force perpendicular to the member, bending moment. You have force times distance will cause moment, or you have a moment, this moment cause twisting to the member, which is called torsion. If you have all of these internal forces will cause stress. So what is the definition of stress? Stress is defined as the intensity of the internal force acting on a specific area passing through a point. The stress can be one of these two types. We have two major types of stress: normal stress and shear stress. What is the meaning of normal stress? What is the meaning of shear stress? It's very important to understand this concept. If the intensity of the internal forces are perpendicular to the cross-section, it will be normal stress. Hey, what you mean by cross-section? I mean, this member has a cross-section here. This cross-section, which is a circle, this is a cross-section. If the intensity of the internal force is perpendicular to this cross-section, this stress is called normal stress. So the normal stress, which is labeled as sigma, is the stress that acts perpendicular to the plane area to which a force has been applied. So the intensity of the internal force is perpendicular to the cross section. What is the meaning of shear stress? If you have a force and this force will cause intensity of the internal force, this intensity will be parallel to the cross section. Here is the cross section. If the intensity parallel to this cross section, not perpendicular, parallel, in this case, it will be shear stress. So the shear stress, which is labeled by tau, is defined as a type of stress or intensity of the internal force that acts coplanar, parallel, with a given cross-section of the material or of the member. Does that make sense? So be careful. These are the internal forces that we will expect in the member. This axial force tension, this axial force compression will cause normal stress. This shear force will cause shear stress because this direction of the force, of the shear force, is parallel to the cross section. This torsion will cause shear stress. This bending will cause normal stress. So, just a reminder, we have different types of the internal forces that we learned from engineering mechanics, statics. These internal forces will create stresses. These stresses can be normal stress or can be shear stress. Keep in your mind, if you have a tension force, will cause normal stress. If you have compression force, will cause normal stress. If you have shear force, will cause shear stress. If you have torsion, will cause shear stress. If you have bending moment, will cause normal stress. This is our course. We are going to work on this concept. The internal forces will cause stresses, two types of stresses, normal stress or shear stress. What you mean by normal stress? The normal stress means the stress is perpendicular to the cross section. Shear stress means the stress is parallel, coplanar to the cross section. Normal stress labeled by sigma, shear stress labeled by tau. We have different units for the stress. By the way, stress represented by a force per unit area. So if we are using SI system, force per unit area can be Newton per meter squared or Newton per millimeter squared. These are the most common units in SI unit for stress. Newton per meter square can be called Pascal. Newton per millimeter square can be called megapascal. That makes sense? So force, this is for Newton, area, this is meter square. That makes sense? If we are using US units, so it can be pound per inch square, which is called PSI, or kib per inch square, which is called KSI. So it's very important to understand these units. So Pascal is Newton per meter square, megapascal Newton per millimeter square. This is for SI units. For US unit, we have something called, which is very common to be used, PSI, which is pound per inch square, and the KSI, which is kib per inch square. So the normal stress can be called axial stress, but axial stress originally is normal stress. So axial stress is the normal stress that is created by axial force. If we have a member and this member under the effect of a force and this force is parallel to the member, so this force will cause axial force. Axial means the force parallel to the axis of the member. Sometimes this force is tension. Sometimes this force is compression. So these axial forces will create normal stress, and this normal stress can be called axial stress. So the tensile stress, the stress induced in a body when it is subjected to tension force. These tension force are pulling the member. This force and this force trying to pull the member, which means tension, which will cause tensile stress. This tensile stress is perpendicular to the cross section. If you look to this cross section, we have a cross section here. This cross section will be under the effect of perpendicular stress. The stress is perpendicular to the cross section. If this force is compression trying to push the member, so if you have forces pushing the member, it will cause compression, and this compression will cause compressive stress. So please be familiar with these expressions. Normal stress that created by axial force can be called axial stress. So axial stress originally is a normal stress. This axial stress can be tensile stress if the applied force pulling or causing a tension. And this axial stress can be called compressive stress, where in the case if you have a force pushing the member and causing compression. Later in the next chapters, we will learn that the axial stress, which is tension or compression, can cause deformation in the member, increase or decrease in the length of the member. We will cover this later. So far, we covered that the axial force will cause normal stress in terms is called axial stress. Also, the bending moment. If we have a member and we have bending moment or bending, this will cause normal stress. And in this case, if you have bending moment causing a normal stress, I can call the normal stress bending stress. So I can summarize what I said here, but let me finish this part first. So the bending stress is normal stress that an object encounters when it is subjected to bending moment. So just look to this cantilever. We have a force F, and here is the cross section of this cantilever. So the cross section at this fixation is this rectangle. If you multiply this force by this distance, you can create a moment. This is from engineering mechanics. Force time distance will cause a moment. So I believe this moment will cause tension in this direction and the compression in this direction, because the moment will be like this. So this cantilever trying to pull this part of the cross section and push this part of the cross section. In between, we have something called the neutral axis. All of these details will be covered later, but this moment will create normal stress. In this case, this normal stress, I can name it bending stress. That makes sense? So for this example, this beam, originally, this beam was straight, rested on this support and this support. And you stand on this beam here. So after you stand up on this beam, the beam deformed like this will cause compression at the top and the tension at the bottom. This tension and this compression is perpendicular or are perpendicular to the cross section. Perpendicular means you have normal stress. So what I can say so far, normal stress can be axial stress, or can be bending stress. So bending stress or axial stress, both of them originally are normal stress. What you mean by normal stress? I mean the axial stress or bending stress will cause stress perpendicular to the cross section. That makes sense? If the applied force pulling like this, it will cause tension. If the applied force is pushing like this, it will cause compression. So if you have tension, we will have tensile stress. So the value of the sigma will be positive. If we have compression force, it will cause compressive stress. That means the value of the sigma will be negative value. Does that make sense? So the stresses here will be perpendicular to the cross section and causing tension like this. The stresses here will be perpendicular to the cross section and causing compression like this. In the case of bending moment, the cross section looks like this. And here is the applied moment. This moment will cause tension at this end and will cause compression at this end. So we have tensile stress and compressive stress at the same time if we have moment. So in between, we will have something called the neutral axis, will be covered later. So we will have stress looks like this. Does that make sense? Part of the cross section under tensile stress, the other part under compressive stress. This part will have sigma equal positive. This part will have sigma equal negative. So this is the meaning of normal stress. Normal stress can be axial stress, can be bending stress. Axial stress if we have axial force tension or compression. Bending stress if you have moment. But both of them will cause normal stress sigma, which is perpendicular to the cross section. That makes sense? Shear stress. As I mentioned before, shear stress is a stress or component of stress which is coplanar or parallel with the material cross section. The shear stress can be caused due to shear force or due to torsion. Does that make sense? So the shear force, if you look to this force, F trying to push this beam down. So if you look to the cross section here, due to the effect of this force, we have stresses on this cross section parallel to the cross section, trying to push it, trying to move down in the same direction of the applied shear force. Or if we have torsion, torsion means twisting. We have a moment, this moment, which is called T, capital T, trying to twist this shaft. So this cross section, under the effect of this torsion, this twisting, we will expect torsion stress or shear stress parallel to the cross section. Does that make sense? So I can summarize this here. We have another type of stress which is called shear stress. This shear stress can be labeled tau. This shear stress can be caused from shear force diagram or shear force. If we have a member and this member under the effect of two opposite forces, so I expect shearing between the two forces. This shearing stress will be parallel to the cross section. So if the cross section looks like this, so the shear stress will be parallel to the cross section. Sometimes the shear stress can be caused by torsion. If we have a member and this member under the effect of twisting, which is called T, capital T, or moment, this moment is twisting the cross section. So I should expect shear stress parallel to the cross section. Does that make sense? So this torsion will cause shear stress. This shear force will cause shear stress. Does that make sense? We have different examples of shear stress, like these bolts. If we have a bolt connecting between two plates, this plate and this plate, due to the applied forces on this plate, this force and this force, we expect shearing in this bolt. Sometimes we have single shear, like this case. Sometimes we have double. If you look here, this plate is pulling to this direction. This one is pulling to the other direction. So I expect a shearing on this bolt at this plane and this plane. So in this case, it's a double shearing because we expect two plane or two planes of shearing. So this is an example of shear stress due to the shear force. I have an example here. This example, we are given a piece of material, whatever the material, and we have two forces, two opposite forces, 2 kilonewton and 2 kilonewton. And we are given this cross section AA, and I would like to figure out what are the values of the forces that will cause normal stress and shear stress. Remember, normal stress is perpendicular to the cross section. Shear stress is parallel to the cross section. Your cross section is something like this. So I need to figure out which force perpendicular to this cross section and which force parallel to this cross section. So I will decide to make cut at AA, and I will decide to use this part after the cut. So here is the section, here is the part I am using. I have a force here, 2 kilonewton. If you apply summation f of x equals 0, I should have another 2 kilonewton here to make sure summation f of x equals 0. This is the cross section AA that I'm looking for. We are looking for section AA, and this section has inclined angle here, theta equals 30 degrees. So if you would like to figure out the force that will cause normal stress, I have to break this force 2 kilonewton to something perpendicular to this cross section. If you would like to figure out the force that will cause shear stress, I have to break this force to a force parallel to the cross section. Does that make sense? So the force perpendicular will cause normal stress. The force which is parallel to the cross section will cause shear stress. That makes sense. We are looking for what is the value of this force, what is the value of this force. So I did my cut at AA. Then I decided to use the left part of this member. I put the 2 kilonewton to make sure this body is in equilibrium. I applied summation f of x equals 0. So I have 2 kilonewton here. I should have 2 kilonewton opposite to make sure summation f of x equals 0. This 2 kilonewton will be broken to two components, one perpendicular, one parallel to the section AA. So it's very critical here to figure out which angle theta. So this angle theta 30, I think 100% it will be the same angle here, theta 30. So this component will be 2 kilonewton cosine 30. And this component will be 2 kilonewton sine 30. So the force that will cause normal stress will equal 2 sine 30, which is 2 sine 30, which is 1 kilonewton. This force will cause normal stress. The force that will cause shear stress equal to cosine 30. So 2 times cosine 30, it will be 1.73 kilonewton. This force will cause shear stress. How to calculate the value of the shear will be covered in the following video. But so far, we are explaining the concept of stresses. Keep in your mind, we have something called allowable stress. What you mean by allowable stress? Let me explain it here one more time. So, what I covered so far, I have a beam like this one. This beam is made from a material like concrete, maybe like steel, maybe like wood, maybe any material, whatever. So this beam is supported by something here, and this beam under the effect of forces. So these forces are called external forces. These external forces will create internal forces. These internal forces can be axial force, can be shear force, can be bending moment, can be torsion, maybe. These internal forces will cause stresses. Is it correct? We learned this. These stresses can be normal stress, which is called sigma, or can be shear stress, which is called tau. And we learned that the axial force, bending moment, both of them will cause normal stress. Sometimes it can be called axial stress, sometimes bending stress, but by the end, it's normal stress. And we learned also that the shear force torsion will cause shear stress. Okay, we learned all of these. How can I make sure this beam, which is made of concrete, will not fail? It's a very important question for any engineer. We have a beam made from a certain material, and this beam under the effect of external force. So the story is the external forces will cause internal forces. These internal forces will cause stresses. To make sure these stresses are safe, or to make sure this beam will not fail, these stresses must be smaller than or equal at least the allowable stress. This allowable stress is a material property. So for concrete, we have a specific value for allowable stress. For steel, we have a different specific value for allowable stress. For wood, we have another value for allowable stress. So if these stresses, which is calculated from these internal forces, which are calculated from the external forces, if these stresses are smaller than or equal the allowable stress, we are safe. That makes sense? So the allowable stress is defined as the material failure stress, which is a property of the material divided by a factor of safety. We cannot take this risk. We cannot take this risk to design your beam to the highest level of stress that this material can support. So we have to take something called factor of safety. So the factor of safety equal the failure stress divided by the allowable stress. Does that make sense? We have factor of safety for normal stress and we have factor of safety for shear stress because each material has allowable stress for normal stress, allowable stress for shear stress, failure stress for normal stress, failure stress for shear stress. So we have two different values for the factor of safety if you are talking about normal stress or if you are talking about shear stress. So the idea of allowable stress is I would like to make sure the structure is safe. I would like to make sure the material of the structure is safe against failure. And we are going to use factor of safety to be more safe. This factor of safety is greater than 1. Greater than 1. That makes sense? The factor of safety is greater than 1. So if you divide the failure stress of the material by the factor of safety, you can get the allowable stress. So if you are given the factor of safety, if you are given the failure stress for a material, I can tell you what will be the allowable stress. To make sure this member will not fail, make sure the calculated stress is smaller than or at least equal the allowable stress. This allowable stress, we considered factor of safety to make sure your beam is safe. And keep in your mind, we have factor of safety for normal stress and we have factor of safety for shear stress. The last part of our meeting today, I will cover something called strains. Strains means deformation. So strain can be defined as the amount of deformation experienced by the body in the direction of a force applied, divided by the initial, the original dimensions of this body. We have two main types of strain also. We have normal strain labeled by epsilon, and we have shear strain labeled by gamma. The normal strain is caused by normal stress. So if you have stress, we have strain. Keep it in your mind. If you have stress, we will have strain. If you have normal stress, I will have normal strain. If you have shear stress, we will have shear strain. The normal strain is called sigma, epsilon, and the positive value means tensile strain, and the negative value means compressive strain. Shear strain is caused by shear stress, will be labeled by gamma. Does that make sense? So if you have stress, we will have strain. Strain means change of deformation. Amount of deformation related to the original dimension of the member. So it's not the amount of deformation and that's it. No, we have to relate this amount of deformation to the initial dimensions of the body. We have normal strain and we have shear strain. Normal strain epsilon is caused by the normal stress, can be tensile strain, can be compressive strain. The shear strain is caused by shear stress, and this one will cause a change in the direction of the deformation. We will cover this in more details. So what I covered so far, I'm covering the concept of strain. How to calculate this strain will be covered in the following videos. So I would like to summarize what I said so far. Strains is deformation, amount of deformation related to the original dimensions of the member. It's not the amount of deformation, that's it. No, it's deformation related to the original dimensions of the member. This strain can be normal strain called epsilon, or can be shear strain, can be called gamma. This normal strain is coming from normal stress. So if you have normal stress, we must have normal strain. And this normal strain can be tensile strain, positive, and it can be compressive strain, which is negative. And that makes sense. If we have tensile stress, we will have tensile strain. If we have compressive stress, we will have compressive strain. That makes sense? The shear strain is caused by shear stress. So if you have shear stress, we must have shear strain. That makes sense? And this shear strain deformation not only cause line segment to elongate or contract, but they also cause them to change direction. We will cover this in more details in the following videos, but so far, keep it in your mind. We have normal stress, can be axial stress. If you have axial force, can be bending stress if we have bending moment. We have shear stress caused by shear force or torsion. We have strains. These strains can be normal strain or shear strain. The normal strain caused by normal stress. The shear strain is caused by shear stress. This story is very important. If you have a member, if you have any structural member made from any material, this member under the effect of external forces like dead load, like earthquake, like wind load, like life load, whatever the external load is. These external loads will create internal forces in terms of axial force, shear force, bending moment, and torsion. These internal forces will cause stresses. These stresses can be normal stress or shear stress. These stresses must be smaller than or equal, at least the allowable stress, to make sure this material will not fail. Keep in your mind, if you have these stresses, we will have strains. The normal stress will cause normal strain. The shear stress will cause shear strain.